Hello everyone, welcome to this video. My name is Amir Senahari, I'm a Google Earth Engine expert. In this video, I'm gonna show you how to do LST monitoring using fine resolution Landsat imageries in the Google Earth Engine platform. A few years ago, when you wanted to have access to the land surface temperature, we had lots of challenges regarding to the algorithm and also equations and the bands and etc. But nowadays, the land surface temperature as a product and ready to use is available for all of the Earth Engine or remote sensing experts in all around the world. Nowadays, thanks to Landsat collection to level 2 data in Earth Engine, we can have access to LST band ready to use without any further processing. And also it's a very valuable product for the thermal related analysis in the Earth Engine and also in the remote sensing studies. So let's go to the Earth Engine code editor. Today I want to show you how we can call Landsat data, how we can select the land surface temperature product, and how we can do monitoring using this kind of product and how we can download them for our studies actually. For the first step, as usual, you need to identify your region of the interest. In this tutorial, I'm gonna select a region in my own country, the capital of Iran, Tehran. You can see this, it is available here. And also it should be noted that this tutorial can be used for all around the world, and it is not limited to only one specific place, because Landsat images globally are available and you don't need to use this data only for one specific location. So for the first step, I want to identify the region of the interest. My region of the interest is the capital of Iran with the surrounded region here, and also it is a combination of the built-up area and also the exposure regions and vegetation covers. Most of the time, we use land surface temperature to analyze and to monitor the temperature changes in the urban areas and also urban infrastructure. So for the next step, we need to have focus on the study area through the map.center object to the geometry. So now for the next step, a new variable needed to assign Landsat image collection on. Make a new variable, for example, this is Landsat image. But as you know, Landsat images regularly available since 1984 and with thermal infrared bands. And also if you want to have access all available thermal infrared bands over the time spans, you need to call all Landsat images separately, Landsat 4, 5, 7, 8, and 9, using separate variables, and then merge all them together into a single image collection, and then do the monitoring process or extract what other kind of information you need. So for the first step, I want to call Landsat 4 images here through the search places and dataset, type Landsat 4 collection to level 2. Actually, since Landsat 4 and thematic mapper sensor thermal infrared band got available, and since then we could monitor temperature of Earth's surface using this kind of product with fine resolution. In that time, the thermal infrared band provided 120 meter spatial resolution that is useful to monitor temperature of different phenomena regarding to the Earth's surface. So as you can see, Landsat collection to level 2 is available here, and already I showed this product in the Earth Engine in the previous videos, but we only use the surface reflectance product in their in the previous tutorials regarding to the NDVI calculation and something like that. But now I want to show you this product also including surface temperature band that is useful for thermal monitoring. Import it into the code and then image collection assigned to Landsat 4, and then set a filter date for your region of the interest. And the filter date, we want to have access to all Landsat 4 images available. And if you go to the data description, you can see that this data is available since 1982 to 1993. And so accordingly, filter date needs a start time and end time, 1990, 1984, 1983, I think. Let's to check it again, 1982 to 1982 to 1990, for example, for 1994. Yeah, and then using filter bound, we want to call all Landsat images just for the region of the interest. By the filter bounds, we are bounding Landsat data to this region. And also possibly our region covered by multiple frames. And also if you want to select a frame that completely cover your region of the interest, you need to get you need to have information about the number of pass and row that's tracking and passing over your study area. If you want to get information in this regard, I think the best solution is earthexplorer.usgs.government, and also I think something is wrong in this website, and also we cannot have access to this website, at least for now. And another solution is that use the Earth engine to see that which kind of paths and rows are available for this region. So here, first use the print all Landsat 4 images. In the right panel, you will see that 38 elements available. Although Landsat provided 16 days temporal frequency, but there are lots of gaps in the Landsat imageries, in the Landsat imagery process before 2013, when the Landsat 8 launched. And also that's why for some period of time in some sensors we have lots of gaps, and also we cannot fill these gaps by some alternatives or something like that. That's what we have for these dates. And also here in the feature, you can see that multiple properties are available, and also we will have some properties regarding to the pass and row. And here you can see that we have pass and row, and also I want to check it out how many pass and how many rows available for this region, and to see that which one covering our study area completely. So here through the dot aggregate array, you can see that how many pass and rows, or how many unique pass and rows available for this region, how many pass available. And also if you want to select the unique one, dot distinct is very helpful to do this. For example, when you run the code, you can see that two passes available for this region, 164 and 165. And here I can write it here. This is Landsat frames, because multiple frames available for this region, and their passes including 164 and 165. And now if we want to see that how many rows available, Landsat frames rows, just like that, and WRS rows, that these things. And then, oh, I think there is something wrong in my code. Yes, one S was extra. So, and you can see that 2 rows also available, and now I want to see that which one of these frames completely cover my study area. So, and here we can check it out we can check it out without any problem. So just make a new filter for the pass and row. Earth engine dot filter dot equal. I want to call all Landsat images including pass 164 and rows 35. WRS pass 164, and then again dot filter, same filter, Earth engine dot filter dot equal, and here we will have WRS row, and row will be 35. So to see the final result, we can get an average image. Map.add-layer. Through the map.add-layer, I want to visualize the average of Landsat 4 images available with these pass and row to make a single image and see that how much this frame covering my study area. So, and also you can get an average, or also you can select one of the images available in Landsat 4, and also you can just write Landsat 4 just like that without further functions. So I leave the visualization characteristic empty, and here is Landsat test. Hopefully pass and rows are same between Landsat missions, and for example when we say that for example this pass and row is useful, it means that the same pass and row will be used and will be applied for the next Landsat generations, and the pass and row codes didn't change or didn't change in the different Landsat missions. So and then false and write the code, and finally we will have an image, and you can see that yes, this frame completely cover my study area, and also I can use this, and sometimes maybe 2 frames completely your region of the interest. Now we can try for the other combinations of pass and row. For example, if we back like this, run the code again, you can see that 164 for passes. Here we have 164 and 165, and for the rows we have 35 and 36. You can make different combinations to see that which one is available for this region, and also to do this I can use different combinations. For example 164 with rows 36, just like that, and run the code. You can see that it's also available, but not including our and not covering our region of the interest. And also the other combination is including 165 and 35, 165 and 35. You can see that yes, 165 and 35 is also available, but it is not covering our study area completely. And with 36, you can see that no images available in this region by this pass and row. So finally we found that 164 and 35 is the best combination, is the best pass and rows for this region. If we have access to the Earth Explorer website, the best way is to find the appropriate pass and rows through this. But if Earth Explorer is not available due to the service interrupted or maintenance process or something like that, the best way to find the appropriate pass and row for your location is using this method in the Earth Engine platform. So after finalizing pass and row code for all Landsat missions regarding to our study area, we can write and repeat this code for the rest of the Landsat generations, and then we can combine and find the temperature data into a single image collection. So I wanna remove the rest of codes that are available. You can remove them all, or you can skip by the control slash and also the double slash, helping you to skip the codes and convert them from a code or a script to a dictionary text, or and also just a simple explanation, and also they don't have any contribution to the further processing or something like that. And also you can use double slash to write something about different parts of your code, and also or skip a part of your code and something like that. So and now I want to use this code to select the thermal infrared bands or surface temperature band. If you go to the data description, in the data descriptions, in the bands, you can see the band's information are available. Surface temperature band number 6 with Kelvin unit is available, and here there is a scale and factor that should be implemented on each available images. Surface temperature band number 6 here is available, and now I am using this band number, surface temperature band number 6, and also to, if you want to remove this from ST band 6 to the, for example, LST, it's very simple to add a new bracket like here and write the alternative name there. So after this, I want to repeat this code for Landsat 5, just like that, with a little changes. Landsat 4, Landsat 5. In the Landsat 5, still the surface temperature band number 6 is available, and we want to turn it into the LST, but the start and end dates could be changed, and also the image collection should be changed. So instead of Landsat 4 collections, into the search places and location or data, we can see collection to level 2 for Landsat 5 is available. And also here, instead of image collection first, we will have the second image collection, and we need to change the start and end date since 1984 to 2013. 1984 to 2013. The same pass row as I mentioned, the pass and row will be same in the all Landsat generations. So next is Landsat 7. As you know, Landsat 6 is exploded and also never reached to the imagery process. So we have Landsat 7, and for the Landsat 7 images, we need to change the name of image collection as with the ID of image collection. Landsat 7 collection 2 level 2 is available, and the main difference between Landsat 7 enhanced thematic mapper sensor with TM and Landsat 4 and 5 is that in the Landsat 7 and ETM plus sensor, land surface temperature is available with 60 meter spatial resolution, and that's the huge improvement in the Landsat 7 data regarding to the temperature bands. So, and instead of image collection 2, we will have the third one, and start and end date is started data starting since 1999 to 2024. It's still available. 1999 to 2024. I want to call all Landsat 7 images that are available. So, And as you can see that the LST Landsat 7 is available, but as you know, part of Landsat 7 images after 2003 affected from SLC off issues, and also because of this problem part of information in each frame is lost, and also we need to retrieve the lost information using the interpolation and filtering technique. So if you search on the net about Landsat 7 SLC off issues, you can see that there are explanations in this regard, and also you can use them to find that since when this problem occurred in the Landsat images. And there is a website in the USGS problem in the USGS websites, and also there are some explanation in this regard. And as you can see, Landsat 7 ETM Plus started since May 31, 2003. So because of this problem, most of information missed in the Landsat frames. If you go to the Google Images, you can see that the stripping problem happened after SLC off problem, but the good news is we can fill this missed information by interpolating techniques. In some videos in my YouTube page, I already showed you how we can do this process, and again I want to show you the same process here, but in this time for thermal bands, for the band including land surface temperature. For the first step, change the Landsat 7 names to SLC on. It is available since 1999 to 2003. Month is May, and also until the last of May, and also I think until the May 29, SLC on data is available, and also we have no problem in this period. And also then make a new variable for SLC off data. SLC off equals to same image collection, same bands, but just you need to change the date. Since 2003, for example, the exact date is the last day of May, or May 30 to 2024. It is still and also still we have a stripping problem in Landsat 7 images, and whenever you want to use Landsat images, you need to you need to fill these gaps before further processing. That's a very important pre-processing step that should be considered when you are working with Landsat data. And in contrast to the other pre-processing steps such as radiometric and atmospheric correction and geometric correction that is already done on collection to level 2 data, but a stripping problem still exists, and also we need to solve them by the filtering technique in the Earth Engine platform. So, and keep the bounds and pass and rows as the same. And now I want to show you this problem in the Landsat images for our study area. And after you knew and after you get information and see that how it affects in our study area, I will show you how we can solve this. Through the map.add layer, so I can visualize Landsat 7 SLC off image just as a sample. Leave the visualization process empty and turn the name to SLC off, and then use false here to avoid from automatic visualization or loading image here. So one SLC off image is loading for this region, and as you can see that the stripping lines clearly available, and you can see that. And also when I apply this, you can see that the stripping problem highly affect on the informations available for this image. That's what it looks like. When you zoom in, you will see more details. You can see that this is SLC of problems. Yes. And also if I check only, and also for example if I select only the first image, you will see the stripping problem clearly, more clearer. So yes, now you can see that how many information lost after a stripping problem occurred in the Landsat data. By increasing the contrast, you can see it very clearly. Yes, that's a problem. And also these are cloud effects, and also we can filter them out from the available images. So for the next step, we have planned to solve this issue in the Landsat data. So for the SLC of, now I wanna make a function and that should be applied on each available images here. So for the first step, we need to make a filter, a variable as filter equals to get from each available IMG, because we already called each input images as an IMG here, get the IMG for each date, and then through the focal median like this we can make a filter for this image, or the radius, for example, as we want to use the first and nearest pixel, we want to set the radius as 1, because we want to use the nearest neighborhood method to fill the gaps. And so here I set the number of pixel radius as 1. The kernel type should be a square, because the pixels has a square structure or a square shape, and the unit should be pixels here, pixels. And iteration shows that how many how much a process can iterate or how many times the process can be repeated in the code, because as much as iteration increases, we can get a better result. For example, when I set iteration to 3, meaning that 3 times computation can be repeated until to find the best result. So remove the kernel here, and then we need to blend this filter with the original image. The next variable is fill equals to blending filter with the original image, that is IMG here. Finally, the function returning the fill image with the properties of input images, dot property names, just like that. And again, I save the code, and also you can save it whenever you want, run the code. And also when we run the code, when the code is running, we face with a problem about the square. The writing style is wrong, the square is like this, and now the problem is solved. And also you can see that the gap filled, the gap filled image is available here, and also without any stripping problem and without any gaps. That is very helpful technique to solve this problem for the SLC of data. Yes, the SLC gap is solved. And also, but this image is a little cloudy, and also limited our ability to see more details here because of the clouds. But as you can see that there are no longer gaps in the images, and now we can use this image for the further processing in the next steps. When you are working with the Landsat monitoring and when you want to combine a bunch of Landsat images for the more than 40 years, you need to consider this kind of problem and use these kind of methods to solve them. So after doing this part, now we can go further for Landsat 8 and Landsat 9. So, and copy previous variable with a little change again. Instead of Landsat 7, we have Landsat 8, image collection for Landsat 8, or collection ID for Landsat 8 images is available here. Collection 2 level 2 tier 1 is available, imported as an image collection number 4. Image collection number 4 is here, but in the Landsat 8 the number of bands changed, and also we need to set a new band name for the LST here. Go to the data descriptions, through the bands, you can see that the surface temperature is band number 10 with the same scale and factor that should be applied on each available image. Instead of band number 6, now we should have band number 10. Copy and paste the new name here, and also the period of time should be updated here. Landsat 8 available since 2013 to 2024. It is still available for the same paths and rows. So, and also we can use Landsat 9 images because Landsat 9 data is available since the late of 2022. Landsat 9, it is also available in the Earth Engine platform. This is Landsat 8, Landsat 9, collection 2, level 2, search it through here, and yes, it's available, import it into the code as an image collection number 5. Yes, there is, and also we want to have access to these data since 2022, and also with the same band name, because in the Landsat 8 and Landsat 9 we have same thermal infrared sensor. It is TIRS, including 2 thermal infrared bands as band number 10 and 11, but band number 10 only used for the land surface temperature. And so in the next step, now we can merge all the Landsat LST data available for the whole period of time. Just make a new product. It is for example collection. This is our image collection equals to, so Landsat number 4 dot merge. By the merge we can merge or combine all image collection into a single image collection. Instead of having multiple image collection, we can make a single one. Landsat 4 dot merge Landsat 5 dot merge Landsat 7 dot we have 2 Landsat 7. One of them is SLC off and one of them is SLC on. Landsat 7 SLC on first, and then we will have Landsat 7 SLC off, and then we will have Landsat 8, and then Landsat 9. Finally, to sort them based on the date, we need to add sort function based on system time start, because the acquisition date information all stored in the system time start with the millisecond format in the Earth Engine. And also this part is really important to sort out all available collections based on the dates. So because you want to do some monitoring techniques and also change detection, and also it is important that have access to all images since the time start to the time end sequential with the sequence with the right sequence actually based on the acquisition date. So in the next step, if I print the collection, you will see in the right panel image collection is computing. You can see that more than 1000 images available for this region, and also since 1984 some images available to 2023 images available, all of them for pass number 164 and row number 35 as we already defined by the filters. So now for this collection we can have access in this collection for each date LST band is available. So now we can make a function to apply a scale and factor on each existing LST, and then we can convert it from Kelvin to the Celsius degree and plot the changes. To do this, make a new variable LST collection equals to get collection first, and then throw the map, import all of them into a function, and each input image is considered as an IMG here, and then make a new variable as bands equals to, or it is Kelvin, LST based on the Kelvin, to get LST based on the Kelvin from each image we call IMG, each image considered as an IMG here, multiply to the scale value that already explained in the data descriptions. Back to the data descriptions, here we have a scale and factor. The factor is 149 multiply scale and dot add to the factor 149, but this is for the Kelvin. And if you want to have Celsius, new variable with Celsius name, get Kelvin image dot subtract it from 273.15. This is a constant value that used conversion from Kelvin to Celsius. And finally, you can rename it as LST Kelvin and LST degree Celsius. LST Celsius. So if you want to have these two bands together as a result, just return first Kelvin that add bands to stack both of them together into a single file with Celsius with the all property of input images dot properties. So print it again, LST collection. In the right side, image collection is under computing. One 1000 elements available for each date, two bands available, one of them based on Kelvin and one of them based on Celsius. And now I want to plot each one of these bands. I want to make a separate plot for each band separately. So for example here I used print user interface chart image dot series. Here we have some arguments. Instead of image collection, LST call. If you want to see LST based on Kelvin, write the band name LST Kelvin. Your region is geometry Tehran. I want to get the average area for the selected region. Earth engine.reducer.mean. Scale according to the spatial resolution in the thermal infrared bands. For some dates it is 100 in Landsat 4 and Landsat 5. Spatial resolution is 120 meter. In Landsat 7 is 60 meter. In Landsat 8 and 9 is 100 meter. We can set 100 as a median value or something close to it here for the as a spatial resolution. Instead of X property, import system time start. The important properties that helping us to get data acquisition, to have all acquisition date in the X vector in the chart. So, and now copy the plot again. Just this time, instead of LST Kelvin, write LST Celsius to have both of them in the right panel. Charts under generating. After a few moments, you can see the variation of the LST based on Kelvin and degrees Celsius, using fine resolution data in the Earth Engine platform. Lots of things that should be considered for the time series analysis in the Earth Engine platform, and also these are primary steps that you should consider in your work, because we want to have access to continuous Landsat data for more than 40 years data processing with fine spatial resolution. So until charts generated, I can make a new part for showing you how we can export the results. It's very simple to export the results. You write export.image to drive, and now by some arguments, we have some arguments. The first is the image you want to get export. For example, call LST collection here. Just select the desired bands. For example, imagine you want to get the LST for LST Celsius. Select the LST Celsius bands and then filter date. Using the filter date, you can filter your data based on a specific period of time. It is available since 1985 to 2020, but here we can just use 1 year or multiple years. It depends on your application. For example, I want to have all images for 2019 start date and 2020 as the end date, and then using two bands stack all of them together, all of them into a single layer stack, and then by the clip you can clip it or crop it based on your location of the interest. So the next argument is the description. The description should be LST Celsius or anything you want, and the scale should be 100 meter, and the region of the interest is geometry. The maximum pixels for each frame you can download or get from the Earth Engine should be equals to 1E13. And the next is CRS spatial resolution. In order to have data with WGS84, write this code EPSG 4326. And if you want to save outputs in a single folder, you can write the name of any folder you want to make it. If such kind of folder didn't exist before, here you can write its name and automatically it will be created in the Google Drive, and then you can go there and download your final result. For example, I am making a new folder as Landsat here, And also these are important things that should be considered when you want to get an export in the when you want to get an export from the Earth Engine as an image. These are very important things that should be considered. And if you run the code again in the task, you can download the results. So as you can see here, the temperature band, the LST values with Kelvin and also with the degree Celsius, both of them are available since 1984 to 2022, and also there are some extreme high and low values. For example, here we have very extreme values. These kind of extreme values comes up when you have high cloud cover in your images. If you want to skip cloudy images, it's very simple. When you have a single image collection here, first we want to set different filters based on the properties. So in the Landsat image properties, we have a property named as cloud cover, and then we can, using this property, I can filter all Landsat images with cloud cover more than, for example, 45%. For example, I make a less than filter because I want to have all images with cloud cover less than to 45%. So less than, the property name is cloud cover less than 45%. So run the code again, and in the task you can see that the LST Celsius is available. Click on run because we already made a function to get export, and also the process of saving into Google Drive started, and also once the process is done successfully, it's turned to the blue color and you can download it from the Google Drive. And now you can see that lots of noises skipped or removed here, but still some of them is available, but lots of the noise is removed because we use the cloud cover filters here. And also before it was like this, and after cloud cover you can see that the monthly variations or seasonal variations of the land surface temperature showing very well, and also it's very interesting and good products that you can use it for the multiple applications such as geothermal studies, such as urban heat island, and also vegetation condition monitoring, drought monitoring, and on it goes. I hope you like this tutorial as much as I do, and if you had any problem or question in this regard, you can feel free to put your comments and also ask your questions in my YouTube page. And also I invite you to watch the other videos available in my YouTube page. There are lots of tutorials helping you to solve your problems in the Earth Engine platforms, and also the example code is also available in for this video in my YouTube page in description part. You can pick it up and also use it in your own projects. So thank you for watching us.